from NRSC-ISRO, the head outreach facility of NRSC-ISRO. He will be coming onto the stage. He will grace the stage. You know, he has the experience of 38 years in that field, and he's going to share the experience of his life so that we can put all of these valuable points in our lives to get the success very soon. Sir, with a lot of respect in our heart, we would like to grace the stage, sir. We welcome you onto the stage, sir. Claps. A big applause, please.
Yeah, good morning, students and teachers and faculty members.
Sir, I would like our student coordinator to hand over the bouquet to you, sir. A big round of applause, please. Go take.
So today we'll be having an overview of ISRO, the journey of ISRO, and the different activities of ISRO, the present developments, the present missions. Next slide. So here you can see ISRO started way back in 1969, and it was a very humble beginning. So during that time, we were not having our own building, no proper facilities. You can see our Dr. Abdul Kalam doing the servicing of the rocket, sounding rocket. And also you can see the ISRO engineers carrying the satellites in hula carts and cycles. So with that humble beginning, ISRO started way back in 1969. And today you can see that we are almost competing with the superpowers, and we are not behind. We are almost competing with them. We are almost in some places third or fourth, or trying to be more ahead. Next. So a little bit of how ISRO started. So as you know, in the 1960s, many people were like dying because there was no early warning system. So this particular, like you can see the India, it is a peninsula. Okay. So a lot of coastal states are there. So during that time, so there was no early warning system and people were dying. So the government of India wanted how the satellite data will be useful for a common man. So this is how ISRO started, that one of the objective, and how the data will be useful for the fishermen. With these two objectives, ISRO started. So if you see the total overall structure of ISRO, how many centers we have? So we have many centers, multiple centers are there. So I will not be talking about more and more centers, only the main centers. So coming to the first, the rockets or the launch vehicles, whatever it is called. So they are manufactured where? At VSSC, Dr. Vikram Sarabhai Space Center. So it is a kind of like, the rocket is a kind of transport mechanism to carry the satellites from the ground, from the earth to the space to the required altitude. So all the design and development of the rockets, whether it is the propulsion systems or the liquid fuel, solid fuel, or different kind of stages, whether it is solid stage or a liquid stage or a cryogenic stage. So all the development is done at VSSC. Now assume that the rocket is ready. Now what else you require? You require the satellites. So we have a center called Space Application Center at Ahmedabad, Gujarat. So there, each and every part of the satellite, the important parts, the solar panels, the transmitters, the receivers, the power supplies, the bus bars. So every components of the satellites, they are manufactured there at the Space Application Center at Gujarat. Now assume that the satellite is also ready, rocket is also ready. Will you launch it immediately? No, isn't it? So you have to test the particular satellites or rocket. So what we do is we bring the satellite to a test center called URSC, URL Satellite Center. So at that particular center, we'll be testing the satellite. So because it is our own satellite, you know what are the different tests to be done, what are the inputs to be given, and what are the desired outputs you are going to get. For example, you have the different kind of, like suppose you take the commercial components in your TVs and all, and suppose you similar kind of the large format displays you have in airports, those are all having the industrial grade components. Similarly, for military grade components you have. Okay, so this particular satellite has to be placed in space, isn't it? So that is the reason why you require the space grade of components. So for that you need to have the different kind of like tests, both the like not only the environmental tests but also the electromagnetic radiation tests. So both the tests are required, and we have thousands of tests to be done. So we have a separate team called the quality SRQA, that is the system reliability and quality assurance, or the quality assurance team, or the quality control team. So they will be testing these particular satellites. Okay, each and every stage they will be setting and will certifying the satellite. So once this satellite is space worthy, then only this particular satellite will be taken to Sriharikota. You may be aware of Sriharikota, the spaceport of India. So the different stages of the rocket and the satellite is being taken to Sriharikota. That is a launching pad. And there you integrate the rocket, different stages, and also the satellite is kept on the top of the rocket. That is called the payload fairing. So in that payload fairing you keep the satellite, and the countdown starts. So when the countdown starts, okay, so the rocket, the combustion happens, the fuel burns. So this particular fuel, you may be aware of the Newton's third law. For every action there is equal and opposite reaction. So here the action is the burning of the fuel. So the reaction is it develops a lot of thrust. The thrust is more than the weight of the rocket. So what happens is the rocket goes up. But every time the earth is like pulling, the gravity is pulling the rocket. So the rocket has to, the launch vehicle has to escape from the gravity of the earth, isn't it? So this particular velocity, the escape velocity is around 11 kilometers per second. So the rocket starts, for example, we take the example of a remote sensing satellite being taken up into space, and we take the rocket, for example, we take the polar satellite launch vehicle. The first stage burns, it goes to a height of around 100 kilometers, second stage burns, third stage burns, fourth stage burns. And generally, if you take the example of a remote sensing satellite, that is around 600 kilometers altitude. So when all the stages burn, finally the satellite is put into orbit with an orbital velocity of around 7.6 kilometers per second. It will be keeping on moving around the earth from North Pole to South Pole with an inclined orbit. That is nothing but the remote sensing satellite orbit, or sun synchronous orbit, what it is called. So once the satellite is in orbit, finally we have to receive the data from the satellite. This does the imaging of the earth. Assume that you are at a height of around 600 kilometers and you're holding a video camera and you're seeing the ground below. So you are trying to take the different photographs or the videos. Okay, that particular imageries or videos is nothing but the satellite data. That particular data we have to like transmit from the satellite back to the earth. So we have a ground station at Hyderabad. So National Remote Sensing Center, we have a satellite ground station which receives the data from remote sensing satellites. This is exclusive center for receiving the data from remote sensing satellites. And also we have other satellites as well, the communication satellites and the navigation satellites, but they are being controlled and monitored from different centers of ISRO. Next. So if you categorize broadly the assets we have, one is the rockets or the launch vehicles, the other one is one more category called the remote sensing satellites. These particular satellites are the low Earth orbit satellites, which are at a height of around 600 kilometers, ranging from 600 to 800 kilometers. That is the altitude. And the next category is the navigation satellites. You may be aware of the navigation satellites. We have so many navigation satellites, the global navigation satellites we have, the regional navigation satellites we have. So that we'll be discussing in the upcoming slides. Then the one more category is the communication satellites. So communication satellites are the geostationary satellites, or the satellites which are at a height of around 36,000 kilometers. So we have three different categories of satellites. The LEO satellites are the remote sensing satellites. The MEO satellites are the medium Earth orbit satellites, which are at a height of 20,000 kilometers. And you have the geostationary satellites, which are at a height of around 36,000 kilometers. Next. So coming to the first origin, where we started exactly the Aryabhatta, the first satellite of India, that is Aryabhatta 9, that was way back in 1975. Then these particular satellites were launched from Russia. You may be aware that it was launched from Russia. Then we made our own satellite, that is the IRS-1A satellite. That was way back in March 17, 1988. So during that time, the satellite weight was 975 kg, and we were not having the capability to lift off and put the satellite into space. So what we did, we gave this satellite to Russia, and from Baikonur's Cosmodrome, they have launched this particular satellite, and since then, we have been receiving the data from this particular satellite at Hyderabad, Shadnagar. So if you see the milestones, how we evolved our rocket technology, the first rocket you can see the SLV-1 and SLV-2 failed, and the first satellite was the SLV-3. So this is having a capability of carrying the satellite which is weighing around 40 kg only. We are having the capability to carry only the 40 kg. Then we again modified or redesigned it and augmented it, and the next rocket was the ASLV, Augmented Satellite Launch Vehicle, which is having a capability of 150 kg. But this was also not sufficient, because to carry a remote sensing satellite, generally the weight is less than 2000 kgs. Then again, we modified the design, and the PSLV, that is a Polar Satellite Launch Vehicle, which is a multiple stage. So it is having a 4 stage. It is having a solid stage, first stage, second stage is a liquid stage, third stage is solid, again the fourth stage is also a liquid. So this was having a capability to carry about 1860 kg. But the navigation satellites are still more heavier. They are around 2500 kg. Then again we have modified this particular rocket to the GSLV Mark II. So this particular rocket is a different stage, like one more stage added, that is the solid fuel and the liquid fuel and the cryogenic fuel. Here comes the cryogenic fuel. So this was having a capability of 2200 kg. But the communication satellites, they are also more than like, it is like more than 2500 kg, around 4000 kg. Then again this particular rocket was modified as a GSLV Mark III, and we have the solid stage, the liquid stage and the cryogenic stage. And the top of the fueled fairing, we keep the satellite. To the left side, to the right side, you can see that particular location. If you want to send a satellite, the satellite is placed in that particular location. Suppose you want to send an astronaut, the crew module has to be in that particular location. And suppose you want to send a scientific equipment or a telescope, that has to be kept in that particular location. Next. So this particular, the SLV and the ASLV, now they are obsolete and we are not using them, and presently we are using the PSLV, GSLV, the LVM, okay, Launch Vehicle Mark III. So these are the vehicles we are using, because the time taken is more. For example, you take the example of PSLV, it will take about 2 to 3 months to assemble and all. And you take GSLV, it may take about 3 to 4 months. But there is but the space market is so high. The space market is so high that people are not ready to wait. They bring the satellite and immediately we have to launch it. So that is the reason why we have made one particular rocket called the SSLV, Small Satellite Launch Vehicle. With this, it is an off-the-shelf item, that is a ready-made item. Ready-made stages are there. So immediately we can bring the stages and integrate it and launch the satellite within around 3 days or 72 hours. We will be able to do that. So that is one advantage of the SSLV. Then again we have the RLV TD. The RLV, the reusable launch vehicle. So with this particular reusable launch vehicle, the advantage is that you can place the satellite into space, and again the part of the rocket will come back, and again you can reuse it. That is the advantage of this reusable launch vehicle. So that is the reason why we have also tested the RLV TD, and this is being carried out. Next. So to the left side you can see the PSLV, GSLV, and in the future, because we want to have the payloads more than 4,000 kg, so we are designing a different kind of rocket engine, that is called the NGLV. That is nothing but the new generation launch vehicle, which can carry a capacity of 9,000 kgs, that is 9 tons. And we are also planning for the NGLV heavy, that is around 12,000 kgs. Next. So these are the different models of the NGLV and the Chandrayaan 4 and the HRLV Gaganyaan. Next. So if you see here the different kind of fuels, so we have the solid fuel, we have the liquid fuel, and we have the cryogenic fuel. So you have the different chemical names. Particularly if you see the cryogenic fuel, what is the combination of this cryogenic fuel? That is the oxygen and the hydrogen. So when you electrolyze the water, H2O, and separate the oxygen and freeze it to minus 180 degrees centigrade, and also separate the hydrogen and freeze it to minus 2 degrees centigrade, it becomes a cryogenic fuel. So you may be aware of like Chandrayaan 1, way back in 2008. So during that time, so the Chandrayaan 1, the main discovery was, we have discovered that there are water molecules on the poles of the moon. So that was the time. So before that, if you take before the 2008, nobody was interested to go to the moon, because almost 40 years nobody was interested to go to the moon, because people thought there is nothing there. So after 2008, now every country started showing interest. Like in 2009, USA, they have tried to go to the moon to find out the dust, to study the dust. And again 2009, the different kind of missions. For example, Peregrine mission was there. Again the Chinese, the Chang missions, Chang 3, Chang 4, Chang 5. The Israel Bereshit mission, like the Blue Ghost mission. Then so many different countries started going to the moon after 2008, when they found out that there is water molecules available on the poles of the moon. Next. So some of the greatest achievements of ISRO. So we have so many achievements. So right back you can see on the screen, so many achievements are there. So I would like to tell where we are number 1 in the world. Number 1. So the first number 1 I will tell you, that is one is the Chandrayaan 1, that we could find out that is water molecules on the moon. So no other country found out, and this particular was a greatest achievement of one of the ISRO achievements. Then the second, way back in 2017, we found out that with the help of the rocket, so we were the first country in the world to send 104 satellites at a time. So in that particular rocket, our main satellite was around 1500 kgs, and other satellites were small satellites, which are belonging to different countries. So a satellite can be a small satellite, it can be a pico satellite, it can be nano satellite, it can be a micro satellite. So that was an achievement. That was way back in 2017. Then again, the Chandrayaan 2. So that was in 2019, Chandrayaan 2. So you may be aware about Chandrayaan 2. That is we are having the best camera. The Chandrayaan 2 has the best camera, that is 20 centimeter resolution we having. That is also one of the remarkable achievements. Then again, coming to the Chandrayaan 3. So we were the first country in the world to land on the south pole of the moon. That also we are the number 1. And again, the Mangalyaan. That was in 2019. In 2019, so there are so many countries who are entered the Martian orbit. So many countries have entered. The USA, the China, the Russia, many people have entered the Martian orbit, but not in the first attempt. So we were the first country in the world to enter the Martian orbit in the first attempt. Then again, not only that, we are having so many different kind of missions. We have the Aditya L1, not only the moon, we are trying to go to the Aditya L1 to find out the solar mass ejections, the solar flares, the solar burst. We are trying to develop some kind of models. That was in January 2024. Then again, recently this year, we have launched along with the USA, that is the NISAR. The USA has, the sensor was the L-band SAR, the frequency of 1.2 gigahertz, and the S-band SAR was the ISRO SAR. And we are monitoring the total Earth observation we are doing, and we are having the opportunity of disaster monitoring, the climate change, and the ocean monitoring we are all doing with this particular NISAR. And also coming to the future missions, there are a lot many future missions what we are planning. Next. So this is about the Chandrayaan 1, what I have told you. So the TMC is a terrain mapping camera. Next. You can see in this particular, the water blue, whatever is showing the blue color, the water molecules and all. Next. So about the Chandrayaan 2, the Chandrayaan 2 you may be aware that is having an orbiter. So along with the orbiter we have Vikram lander, and inside the Vikram lander you have the Pragyan rover. Next. So Chandrayaan 2 is having the camera, that is a TMC camera, what I told you, the terrain mapping camera which is having the best resolution, that is about 20 centimeter resolution we are having. Next. So about the Chandrayaan 3, how we went for on July 14th we started from the Earth, and from the Earth orbit how we have gone to the Moon orbit, that particular diagram you are able to see. So here we are accelerated around we increase the speed around the Earth and reach a speed of about 28,000 kilometers per hour, and finally entered into the Moon orbit. And when we entered the Moon orbit, then we have decelerated the speed. So this is how we we landed on the Moon on the August 23 and became the first country in the world to do so. Next. So this is the original picture of Chandrayaan 3 taken by Pragyan rover. Next. So what are the findings of the Chandrayaan 3? So I would like to tell you some of the findings. What we found out that with the chastity sensor, when we drilled up to 10 centimeter, we could find that the temperature on the surface of the Moon was 60 degree, and just 10 centimeter below, it was minus 10 degree. That means almost like 70 degree difference is there. And this particular regolith or sol of the Moon, it is like acts like a very good insulator. That was one of the findings of Chandrayaan 3. And the second finding was a lot of minerals. The minerals, rare minerals like the titanium, chromium, manganese and all, these were found, and also some of the tests like the quakes on the Moon. So there are several tests, some of the tests only I have listed here. Next. So future missions. So some of the future missions today, our chief guest Shubhanshu Shukla sir is coming. He will be taking the lecture next. So he is a part of the Gaganyaan mission. Then again we have the Chandrayaan lunar missions. We have the Chandrayaan 4. We have the Chandrayaan 5 in future. And we have the Venus mission and the Bharat Antariksh Station, and also the Indian on the Moon. These are some of the ambitious missions of ISRO. Next. So coming to the Gaganyaan mission, so what is the objective? The objective is we want to test the particular Gaganyaan to a height, we will be going to a height of around 400 kilometers. So we want our own rocket, our own astronaut, our own space food. We don't have any foreign collaboration, don't want to use any kind of foreign collaboration and all. We want to have everything our own and try to go to a height of around 400 kilometers, and at that particular height, do the different, around 2 to 3 days, we will be doing the scientific experiments, again come back to Earth. That is one of the objective. And the second objective is like space tourism. So with these two objectives, the Gaganyaan project has started. So this is an example of how the space tourism is planned. You may be aware of the Blue Origin, Jeff Bezos, the founder of Amazon. So he's already running a company where these particular passengers are being taken to a height of around 100 kilometers, and they are experiencing microgravity. Around 200 seconds they will be like in the microgravity, and they'll be floating there. Again they will coming back to the ground as astronauts. So this is a kind of space tourism having much demand. So this is the Gaganyaan. So we have the human rated launch vehicle. So you have the different stages, liquid stage, solid stage, and the crew module you can see. The top one is the crew module and the bottom one is the service module. So the astronauts, the Gaganyatris will be going in the crew module. Next. So these are the Gaganyatris who have been selected, and out of which Shubhanshu Shukla is there, you may be seeing, and Angat Pratap is there. So this particular, you may be having the next lecture by Shubhanshu Shukla sir. So he'll be explaining more about it. Next. So not only Chandrayaan 3. So Chandrayaan 3, what we did is we tried to land on the Moon, okay, and do these different kind of experiments. Now we are planning for Chandrayaan 4. The main objective is we want to go to the Moon and then take collect the regolith or the soil or the rocks on the Moon and bring back safely to the Earth. For this, you require extra stages. That means we have ascender on top, then you have the descender, then you have the transfer module, then you have the recovery module and the propulsion module. So the propulsion module will take you from the Earth orbit to the Moon orbit, and again, so when the lander, the descender, when it lands on the Moon surface, so the robotic arms, they will scoop down the regolith or the rock and they will put it in the ascender. So the ascender from the Moon, it will eject from the Moon, and again it will go and join the transfer module and the recovery module. And from that ascender module, the regolith or the soil or rocks, that will be transferred into the recovery module. And the recovery module with the transfer module, again they will be coming back to the Earth. They will start the journey to the Earth. And when it nearing the Earth atmosphere, the transfer module will be separated, and only the recovery module with the help of parachutes, it will come and it will land in the ocean or sea or wherever it is, and our people will go and collect that material. So this is about the Chandrayaan-4, which we are planning in near future. So this is also one of the ambitious mission of Bharatiya Antariksh Station. So we have the base module, we have the core module, science module, common working module, we have the common berthing module and the lab module. So these are the modules. So what is the requirement? The requirement is we want to do the different kind of experiments, like the microgravity research we want to do to find out the muzzle loss and all, and also to grow the plants in microgravity, the space biology, material science, earth observation, so many different kind of experiments we can do in this particular Bharatiya Antariksh Station. So we are also planning. So you may be aware of ISRO Space Station. Already it is there, and it is a combination of, it is supported by 5 different countries. Okay, so we also want to have our own Bharatiya Antariksh Station. Next. So I will take example of 2023. So you can see in 2023, the first, in February 2023, we have launched the SSLV. Then again in the same year, next month, we have launched the satellites which are belonging to the OneWeb Technologies, that is a European company. 72 satellites we have launched. Then again in April 2023, we have launched remote sensing satellites which are belonging to the Singapore. Then again we have launched our own GSL, with the help of GSL F12, we have launched our NVS satellite. So you can see in this particular year, we have launched so many satellites. So now you can see that earlier we were taking our satellites and going to the foreign countries and paying money and launching our satellites. But now you can see that the foreign companies are coming to India and they are trying to we are trying to launch the satellites from our Indian soil. Why? Why? Because it is cost effective. We are cost effective and more reliable. That is the reason why lot many foreign countries are coming to India for launching their satellites from Sriharikota. Okay, so by this we are getting lot of revenue also. So in the year 2023 we got around 20,000 crores foreign exchange. Not only we are getting saving foreign exchange also, but also getting foreign exchange. So that is where we stand now. Next. So you can see that the space market space potential is very, very high now. You can see lot many companies coming up. So the new space policy has changed. In November 2023 onwards, we have a new space policy, and we have the NSIL, the New Space in India Limited, and also we have the InSpace, Indian National Space Promotion and Authorization Center. So these are the two bodies, regulatory, that is, InSpace is a regulatory body, and the NSIL. The NSIL is it will do the services, launching services, or the satellite management service, or whatever services are there, it will be doing. So lot many companies are coming into, the entrepreneurs are coming and all, they're trying to come into this particular field now. You can see lot many emerging companies. Next. So till now we have seen what are the different kind of the space mission, how ISRO started, and what are the different future missions. Now coming to how do we acquire the data from a satellite? Which satellite? Remote sensing satellite. So NRSC, National Remote Sensing Center, acquires data from the remote sensing satellite. Okay. So the main purpose of the objective of NRSC is satellite data acquisition, satellite tracking, processing of the data, then dissemination of the data, generating the different kind of products, and dissemination of the data to different users. So who are the users? The users can be a central government agency, the users can be a state government agency, the user can be like any private company, or maybe a small country, those who are not having a proper ground station or not having their own satellites. So NRSA receives the data from the remote sensing satellites. So as I said earlier, we have a ground station with a huge parabolic dish antennas for getting the faithfully, if you are getting the data from all the remote sensing satellite, both Indian as well as foreign. So how we get the data? What is the principle? What happens is when sunlight falls on the earth, different objects will have different reflections. For example, you have white color, it will have maximum reflectance. If you take the black color, it will have maximum absorption. So these reflections are received by the satellite. Where is the satellite? The satellite is a height of around 600 kilometers. At that particular height, we have a very powerful camera, CCD camera. Okay, so that will receive this optical energy and come and this will again it is like converting that particular optical energy into analog digital voltage. Okay, so after that analog digital voltage, then again we are doing the different kind of analog to digital conversion and lot of processing we are doing. So whatever the processing we are doing, that is called the space segment. On board the satellite we are doing like the randomization, the modulation, the compression of the data, the encoding of the data. So many different processes will be doing on board the satellite. And from the satellite again, we are going to receive the data at the ground. That is the ground station. So it is a high, big parabolic dish antenna with a figure of merit. High G/T it is called, gain over noise temperature. So that particular antenna will receive the data from the remote sensing satellites. So this is how the satellite takes the imagery, the ground trace of these particular satellite. It has a particular path and a Okay, so time is very less, so we will try to close early. Next. So these are the different kind of resolution of satellite. We have the best resolution satellites like 25 centimeter resolution is also available with our Indian satellites, and also we have kilometer resolution, we have meter resolution. For example, you take the remote sensing satellites, we have the LIS-3 sensor, we have the LIS-4 sensor, and we have so many different kind of pan sensors are there. So you can see the different resolutions. Next. So the different kind of satellites sensors we have the passive sensor which is totally dependent upon the sunlight, and also we have the active sensor, that is a microwave sensor. So what happens in the micro sensor is, it is like all weather proof satellite acquisition. That means irrespective of day, irrespective of night, irrespective of all weather conditions, you will be able to receive the data from the satellite. That means it will illuminate the target, the satellite will illuminate the target with the frequency, and whatever the backscatter is there, that will be received by the satellite. So you know the time transmitted, you know the time received. So once you know the time transmitted, time received, the delta t, that is again being converted to fast Fourier transformations, and finally the time domain signal is converted into the frequency domain signals, and you will be able to see the data. So particularly this is very useful for the disaster management. Next. So we have a fleet of satellites, that is the Indian satellites what we have. You can see the list of passive satellites, the OceanSat, the Cartosat, ResourceSat, and you have the active sensor satellites like the ReSat. Next. So we have this station at Hyderabad. So you have a coverage, limited coverage of to the left side and the right side, 3,600 meter radius. Beyond that you cannot see because of the curvature of the earth. So here in this particular communication is the antenna should be able to see the satellite, and the satellite should be able to see the antenna. Then only the line of sight communication takes place. Next. So this is how the movement of the antenna takes place. Elevation movement 0 to 90. Next. Next. This is other movement. So this is how the tracking takes place at the ground station. So when the satellite comes into the vicinity of the ground station, what happens is so assume that the antenna is at 0 degree elevation, and also the satellite is 0 degree elevation. As the satellite rises in the horizon, so if the elevation is 5 degree, for example, so at that particular elevation, once the signal is received by the antenna, the satellite transmits the signal, the antenna starts auto tracking. So this particular mechanism, the depiction you can see here. Next. So this is one of the ground station, how we receive the data from the satellite. So once from the satellite, so once when data is transmitted, it is received by a parabolic dish antenna. So parabolic dish antenna is a huge antenna. The diameter is around 7.5 meters. Then it is having a because at the input of the satellite, at the input of the antenna, so you receive very feeble signal, very feeble signal. So you require some kind of LNA or the LNB, and that will amplify the signal, and that particular high frequency. Suppose you take the example of a particular satellite, Indian satellite, the frequency, for example, it is 8 gigahertz. It is 8125 megahertz or 8300 megahertz. So that particular frequency, it is converted to a lower frequency, that is into the S-band frequency, and that is nothing but the IF. And then that is from the pedestal, it is like being transmitted from the pedestal to the control room. And again in the control room, it is given to again a different kind of like a frequency down converted from 2 gigahertz to again 720 megahertz, for example. So that particular 720 megahertz signal, it is given to a demodulator, and here the carrier is separated, and the signal and the data is separated, and the data and clock is generated in synchronous with the incoming data. And that data and clock, that will be frame synchronized. After frame synchronization, again it is converted into serial to parallel conversion. After serial to parallel conversion, again we are generating an interrupt and trying to ingest the data, and also ingesting the data and also seeing the data in real time. So this is a block diagram how we receive the data from a satellite. So these are the different kind of frequencies. So you can see the L band frequency, the S band frequency, X band frequency. So we are using all these particular frequencies for acquiring the data from remote sensing satellites. So generally the data, as if the data rate is low, satellite data rate is low, then you can go for the lower frequencies, that is the L band. And suppose the data rates are very high, when if it is very high, then you have to go for the X band or the KA band or the KU band. Next. So we have multiple antennas, you can see depending upon the frequency and band which it is operating. Next. So we have a station at Antarctica also. So what is the requirement of keeping a station at Antarctica is that from the North Pole to South Pole, so whenever the satellite is crossing the South Pole, so each and every, from the Shadnagar, for example, from Hyderabad, for example, we are able to see two passes in the morning and 2 passes in the evening, for example. But at Antarctica, you will be able to see more than like 10 passes and all, because always the satellite is going to cover the South Pole. That is the advantage. So we have a station at Bharati, that is called the Bharati station at Antarctica. Next. So these are some of the fix. So this is how we acquire the data at Bharati. So we have like a ground station there similar to the Shadnagar ground station. We have the data reception antennas. So these data reception antennas, what they will do, they will acquire the data from the remote sensing satellites, and they will uplink the data with the help of the data communication antenna. This particular data communication antenna will again transmit the data, uplink the data to the geostationary satellite, and from the geostationary satellite again it is being received at Hyderabad, that is having a data reception. So this is how we receive the data from the Antarctica ground station. Next. These the temperature, because the temperatures are very like it is minus 65 degrees centigrade, you need to have this kind of suit. Next. So some of the very rare birds only you have to see, that penguins, and we have the petrel bird. Next. Next. We have very limited mammals. Next. Next. And you can see particularly when the sunlight particles, because of the huge with heavy magnetic field, you have this kind of aurora lights are seen. Next. Next. This is the control room of Antarctica. Next. This is inside the Antarctica. Some of the pics, some of the pictures taken by the remote sensing satellite. You can see our Hyderabad area, our Tangmand. Next. Part of Mumbai. Next. Dubai. Next. This is a solar panel which is at Kurnool. Next. This is a dust storm. Next. Next. So now we have talked about the remote sensing satellites and some of the navigation satellites which we are going to discuss now. So we have the global navigation systems. So you may be using mobiles in your day-to-day application, isn't it? So all the like navigation related satellites, the GPS what you are having in the mobiles, if you see the right side, that is the US GPS. So one particular plane that is, it is having 4 satellites, like that you have 7 planes. 7 into 4 is 28 satellites. So all these 28 satellites, so how they are configured is, any satellite at any given point, you should be able to see minimum of three satellites. For example, you are in Hyderabad, you will be able to see 3 satellites. Suppose you are in, for example, you are in the middle of the Amazon forest, you will be able to see minimum of 3 satellites. Suppose you are on Mount Everest, top of the Mount Everest, you will be able to see minimum 3 satellites. So this is a configuration where you are having the total number of satellites are 28, and you will be able to see, you will be able to know the positioning, navigation and timing at any given point of time. Next. So these are the global positioning satellites and the navigation satellites. Go to the last slide. Okay. So there is a facility called OUTRECH facility, NRSC OUTRECH facility at JD Metla. So those colleges and schools who are interested, they can apply, they can come to NRSC JD Metla, and you can please note down the email address, outreach@nrsc.gov.in. So those who are the colleges are interested, they can come to our facility, which is at JD Metla, NRSC JD Metla. There is OUTREACH facility. Next. And particularly the students who are going to pass out your engineering degree. So I think all of you are engineering college students. So the students who are completed, are going to complete the branch of engineering specialization, electronics and communication, or artificial intelligence, or machine learning, mechanical engineering, electrical engineering, instrumentation engineering, data science. So any branch of engineering, so they can write an exam called the ICRB. If you want to enter ISRO, there is exam called ICRB. So that particular examination you have to write, and after passing out the examination, you will be having the interviews, and if you are selected, then you can enter the ISRO as a scientist C. So that is one of the opportunity you have after doing your engineering. And for direct entry, so those who are after intermediate, you can write there is a university called IIST, Indian Institute of Science and Technology. So that particular, it is a deemed university of ISRO. So you can write that exam, and gate score also is applicable. JEE exam is also, score is also applicable. So that is also direct entry, and this is a lateral entry. So with this, I stop here. Thank you very much.
Thank you so much, sir.